Hello students, now we would be discussing about the most important part, that is introduction to peptide bonds and classification of proteins. Let's start with the first, that is formation of an peptide bond. Now the structure of proteins are nothing but the structures originating due to formations of an peptide bonds between many smaller units called as peptides. Let's see this. We have an amino acid which was something like this, wherein you have a central carbon attached to NH2 on the extreme left, then you have C double bond OOH onto extreme right, H and R. Instead of taking one, I take two amino acids, and now whenever I combine these two amino acids, that is whenever I heat them together, what happens is I am getting a water molecule is lost. That means now H and OH with from two opposite amino acids combine to give me water, and along with this all the remaining groups they combine together to give me a compound that would be called as an peptide. Now the bond, that is C double bond ONH, is a bond which is referred as an peptide bond. As in this case you are using two molecules, you're getting a compound called as dipeptides. Similarly, if you use 3, you would get tripeptides. If you use 4, you would get tetrapeptide, and so on. So students, what if I use many peptides? Then obviously we would be getting a compound in which there would be larger number of peptides joined together, and this molecule would now be called as an polypeptide, a structure something like this. Now in this case what we can observe is the chains are starting or elongated from both the ends, but now in this case the first end towards the extreme left is a nitrogen terminal, whereas the last end towards the extreme right is a carbon terminal. Moving further, now let's try to classify these proteins based on their molecular shapes. Then they are classified into two categories, globular and fibrous. First one, let's start with globular. They are soluble in water, whereas fibrous, they are insoluble in water. Next, globular, they are folded in such a way that they form a spherical shape, whereas fibrous, they are long, thread-like, and tends to lie side by side to form fibers. Next, the third point for globular is they have intermolecular hydrogen bonding and have weak intermolecular forces of attraction. Whereas fibrous proteins, they are the proteins wherein the polypeptide chains are held together by hydrogen bonds. And lastly, the fourth point is example. Example for globular proteins is hemoglobin, whereas example for fibrous is keratin in hair. So, this was all about this module. Meet you in the next module. Till then, thank you students.